Chapter 4, Quadratic Functions and Factoring. I say day 4, it's 4D. I'm going to probably have more than one, or I'm going to have more than one video. So this will be part 1. And I just don't think you can have enough examples. Some people are going to remember this from Algebra 1 and be good to go, but I want you to have plenty of examples to look at if you're not seeing where all the parts come from. So I'll do a bunch of them, watch what you need. What does standard form look like, we'll start with. What you should always check for first to save yourself some work. Can any quadratic be factored? Where do I find A, B, and C? And once I find them, what do I do with them in this factor for grouping stuff? So before I even get into factoring, I need to do a little bit of talk about standard form and what we're doing with these things. So standard form of a quadratic is in the form ax squared plus bx plus c. Notice that it's in descending order, x with the 2 exponent, x with the little invisible 1 exponent, and then just the constant, which really is x to the 0 power after it that's invisible, but standard form, descending order of the exponents. So, for example, if I gave you this you'd need to put it in order if you were going to factor it by putting the x squared term first and then the x term without the squared and then the 3. Okay, so make sure that before you start doing anything that it's in standard form. And when we're factoring, it's really a type of dividing, and so before we do the dividing, I'm going to do an example of what the multiplying would look like. So if I had 2x minus 1 and 3x plus 7, and I wanted to multiply those, you guys might have learned to multiply those using FOIL. You might have learned to multiply them using the box. You might have learned to multiply them just called double distribution. Lots of different ways, but since we haven't done much of it or any of it, depending on when you've watched this, let's do a little example here of what forwards look like, because when we're factoring, we're going to be going backwards. So to use the box to multiply this, we just put one term across the top and one term down the side, and then we just multiply the outsides time to get the inside. So 2x times 3x is 6x squared. 3x times negative 1, I'm going to do the row first. So 3x times negative 1, negative 3x. So we really just distributed 3x times 2x minus 1. You can think of it like that. And then we're going to do this row, and we're really distributing 7 times 2x minus 1. So we have 14x minus 7. And now that we have that, we have all the parts. I'm going to write a plus there because we're going to combine these to write a trinomial out of that. And so the answer to this being the question, the answer will look like 6x squared plus 11x, because I combine the positive 14 and the negative 3, minus 7. So what we're going to be doing when we're factoring is going in the reverse, where this will be the question and this will be the answer. So the first example that I'm going to do, it's not going to actually have the first step in it. I want to do a fairly simple one first. First example, we've got 2x squared plus 11x plus 12. The instructions on all these are going to be factor. That's it. Factor completely, you might say. And so what we're going to do first is I like to put, I like to keep a clean copy of the problem, make sure it's clear what the problem was when I started versus where my work is and where my answer is. So A equals B equals C equals, I like to pull those out first. And from this point, you guys might know various ways to do this work. Again, you should have had this in Algebra 1, and I know it's been a long time, but if you remember it and you have a way that works for you, great. It can't be guess and check. So some of you would probably do this part of it with the magic X. If you like the magic X, go for it. I use the T-chart, and I'll show you what I'm going to want you to do extra if you're using the magic X. So what we're always going to do is we're going to take A and C, we're going to multiply them on the top. So in this case, that's a positive 24. And then I'm going to write B off to the side. That's a positive 11. So these two numbers would be the top and the bottom of the magic X if you use that method. But I like the T-chart because I want to write all the factor pairs. If you want to write the factor pairs off to the side somewhere, that's okay. But I will ask you to show me the factor pairs. It's a really good exercise. It's some of you don't do so well at dividing, I've noticed. So this should help some of those skills, just a little bit more practice on these things. And I like to go in order because, again, there's a nice pattern to it, and it'll help you remember some of these tips. So we know it's always going to be 1 times the number itself. We know 2 goes into it because it's even. And this one I'm just going to go through because I think you know all those. But on the next one I'll talk about some thought processes you can go through. So there's all my factor pairs, and then how do I pick which pair? They could all be positive because positive times positive gives me a positive, or they could all be negative because negative times negative would give me a positive. But because I'm trying to add up to a positive number, it's going to end up being positive 3 and positive 8 because positive 3 times positive 8 is positive 24, and positive 3 and positive 8 added together give me 11. So that's the pair. So now I'm going to go and I'm going to start filling in the inside of the box. When I did that little pre-learning example, we had the numbers on the outside of the box and we filled in the inside. This time we're going to fill in the numbers on the inside of the box to find the numbers on the outside. So the first box always gets filled in with the first term, and the last box always gets filled in with the last term. And then from here, we bring over the 2 terms from our chosen factor pair. Notice we had this guy came from here, and this guy, whoops, this guy came over here. Those are interchangeable. I could have put them in either position. There's nothing special about that particular position, and they both got an X attached. So that's where all that came from. Now we're just going to factor out what they have in common, the opposite of what we did before. So what do the 2x squared and the 3x have in common? Just an x. What do the 8x and the 12 have in common? They share a 4. The sign we're always going to get from here. Now I'm going to move on to columns. What do these guys have in common? The 2x squared and the 8x? They share a 2x. And what do these guys have in common? They share a 3. Remember, we're always going to take this sign. So my answer is going to be 2x plus 3 and x plus 4. Nothing special about the order I wrote them in. We could also say x plus 4 and 2x plus 3. You do not have to write both of them. That's my answer. I just want to make sure you know that order doesn't matter. Okay, so I'm going to write down the steps on those. And again, I mentioned the first step we didn't have to perform. I didn't want to talk about it while we were first getting started. Step 1 is to factor out a greatest common factor if possible. There was no greatest common factor on this one. I'll make sure the next one has it. Step 2, we listed A, B, and C. Any of these steps along the way that you need more detail, you write in more detail. It's your notes. If you have any questions along the way, write questions. These are your notes. Okay, step 3, after we listed A, B, and C, we made the T-chart, or if you want to say the magic X, we made the T-chart and used A, B, and C, because sometimes people forget about A, because when A is 1, we can get lazy and forget about it. So then we use the t-chart to find the factor pair that was going to work for us. Again, I'm not going to write detail about what made it work here, but you can put that detail in if you like. Find the factor pair that we're going to use. Step 5 was to fill in the box. Again, you can put more detail here if you'd like. Step 6 was to factor out the GCF of each row and column in the box. Step 7, just write your answer. But make sure we talk about the vocabulary. What our answer will be there is 2 binomials. All right, binomials, 2 terms in each of those expressions. Okay, so a lot of steps, but the first one always takes forever and they go fairly quickly after that. Okay, so this one we're going to end up having a GCF, I promise you. We're going to do 9x squared minus 3x minus 30. So that's my initial problem. Before I start trying to pull out an A and a B and a C, I'm going to say, hey, I really don't want to have to try multiplying negative 30 and 9 and ending up with 270. I notice that 3 goes into all those things, so I'm going to factor out a 3. And that 3, we don't use it until the very, very, very final answer. So now we can write our A and our B and our C. We're ready for our t-chart. We want things that multiply and give us negative 30. That was A times C, positive 3 times negative 10, and that add up to negative 1. So I'm going to list the factor pairs. I'm going to ignore the sign. I'm going to worry about the sign when I've got all my pairs listed. 1 times 30 gives me 30. 30 is even, so I know 2 goes into it. Right? Notice when we double this side, we cut that side in half. Okay, I know 3 goes into it. If 3 goes into this number, let's say, for example, I didn't know 3 went into 30. I know you know 3 goes into 30. But if you weren't sure, but you knew 3 went into 15, then that means 3 goes into 30. So 3 times 10. And then I know 5 goes into it because I have 5s over here and 0s over here. 5 goes into it. Let's say I know 5 goes into 10. Well, 5 goes into 10 twice. So I'm cutting this one in half. So I'm doubling this one. Again, I know you know the factors of 30. I'm trying to remind you of some little tricks and things to think about when you're doing harder numbers. So ask me about those if you're not sure. Alright, so I said we ignored the signs up until now. We want a negative 30. So if we have a negative up here, then either all these guys are negative and the second column's positive, but if I did that and I added across, I'd get 29 and 13 and 7 and 1. That's not going to work. So it can't be those numbers that are negative. We're going to have to try the other numbers. And you'll notice that when you have a negative on the top and a negative on the bottom, then it's the bigger numbers on the right that are negative. I wish I would have left a little room because those look like plus signs, but this is the one we're going to use, right? 5 minus 6 is negative 1. Okay. 5 times negative 6 is negative 30. 5 plus negative 6, or 5 minus 6, is negative 1. Alright, so we're ready to start filling things in the box. And again, if you don't like the box and you just want to do this the horizontal method, Awesome. I am just fine with that. I taught that for 8 years. Not a problem. What goes where? Remember, we're not going back to that 9x squared part. We're going just to the 3x squared part. First term, first box. Last term, last box. What we're doing is we're chopping that negative 1x into 2 parts. We're chopping it into the positive 5x part and the negative 6x part. Notice when I add those two together, I'm going to get negative 1x. That's where b came from. Now I'm going to factor, what do these guys have in common? The row, just an x. What do these guys have in common? A negative 2. We always take this sign. What do these guys have in common? A 3x. What do these guys have in common? A 5. Always take this sign. So my answer is 3x plus 5 times x minus 2. Now we bring in that 3. So not till the very end. It is one of the factors, but we already factored it out. We don't need to do anything more till the end. So I would go back and fix that last step if you wrote out those steps and make sure that you know to bring that back at the end. I said write it as a product of the two binomials, but got to remember to bring that GCF back in. Okay, let's do 4x squared minus 21x plus 5. Now, we've just been factoring, but on this one I'm going to give you a little preview into what we're going to be doing as far as, melding this with the graphs. So I'm just going to go ahead and factor it first, but then I'm going to show you, actually I'll start graphing it just before I factor, so show you what we're actually doing when we're factoring. When I see this, I have the same old a is a, so a is 4. So again, this graphing is not part of your homework. This is just to sit back and watch, so you can tie it together later. A is 4, so we know it's going to open up and be skinny. The 5, the C, is going to be your y-intercept still. So 1, 2, 3, 4, 5. I'm just going to go 1, 2, 3, 4, 5 because I know what this graph is going to look like more or less. And so right now we only have 1 point, but we know it's skinny and opens up. So if we had some multiple choice graphs to pick from, again, this is assuming it was written as a function or as an equation. Either way, it could look like that or it could look like that. Oops, I forgot my x in the previous one. Okay, so if we have that and we're starting to graph it, we can always graph the y-intercept. It's in the same place it is on a line. We use the a to know that it opens up and it's narrow, it's a stretch. Now let's factor it and say, what is this factoring getting us? So we've got no greatest common factor. Nothing goes into 21 that goes into 4, so we know we're done there. A is 4, B is negative 21, and C is positive 5. We're looking for things that give us 20, that's A times C, and add up to negative 21. Our factor pairs 1 and 20, 2 and 10. Nope, no 3. 3 doesn't go into 20. 4 goes into 20. Okay, now this is a positive, and remember, either all of my factor pairs are positive, but since B is negative, they're all going to have to be negative, because negative times negative will give us a positive. The only way to have the same signs and have it end up being negative is if they're both negative. So that's the one that we're going to use. First box, first term, last box, last term. Bring these two guys over. These guys share just an x. These guys, it's going to be negative 5 because we take this sign. 4x squared and 20 share a 4x. And this is just going to be negative 1 because these guys don't share anything visibly. It's just going to have to be a 1, but we take this sign. So my answer to this problem, the factoring problem, is x minus 5 and 4x minus 1. But the little preview, so that's the answer for today. Our little preview is, if we were actually going to be graphing this, we say, well, we know that the x-intercepts are, I can show the factored form of this. You're going to see this is called intercept form. And I know that the answer to this little baby equation, this is just a preview of what we're doing in the next couple days, the answer to this little baby equation is 1/4. So that's one of my x-intercepts. And the answer to this little baby equation is positive 5. So that's the other one. We'll learn how to get the vertex, but we've almost got enough to, just do a rough sketch. I don't know how far down the vertex goes, but again, if it was multiple choice, we probably wouldn't have that big of a deal. Okay, so I'm going to do another video with more examples, but these are the basics. There's some special cases as usual, but these are the basics. So what does standard form look like? Ax squared plus bx plus c. Always check for that GCF. Can any quadratic be factored? I didn't address that because I got in a rush. No, and I'll make sure we talk about that more on the next video. We talked about where to find those and what to do with A, B, and C.